biochemistry in a moment, and we're looking at polyfunctional compound. To know what something is, the best way is to know what it is not. I take that again. To know what something is, the best way to know what something is to know what it is not. Now, when you look at the word polyfunctional compound, remember we will also have monofunctional compound. Then we also have bifunctional compound or difunctional compound. Then we now have polyfunctional compound. So let's call this 1, let's call this 2, let's call this 3. So this is monofunctional compound, bifunctional compound, and polyfunctional compound. Now, what do we mean by the word monofunctional compound? These are compounds or molecule that has one functional group. These are compound molecules, organic compound or molecules that has one functional group. When we talk about the biofunctional compound, these are compounds or molecules that has two functional groups. And we're going to give the examples of those. When we talk about the polyfunctional compound, these are molecules or compounds that has two or more functional groups. Remember, there are some polyfunctional compounds that are also examples of biofunctional compound. That's why the definition of biofunctional compound is that they are compound or molecules that has two or more functional group. All right? Now, let's take the first one. Monofunctional compound. In monofunctional compound, let's look at the word. What's the meaning of the word functional? Functional group. The word functional is derived from functional group. And functional group are group of atoms that depict or identify or shows the characteristics of the compound. A functional group is a group of atoms that shows or that represents or that depicts or that predict the characteristics or the behavior of the compound. All right, now let's give an example of a monofunctional compound. We're going to go back to the knowledge we have in chemistry under organic chemistry. We're going to name just two and then we'll move ahead. Now let's say we have this. Okay, let me give the functional group first. We have the alkanol. The alkanol, which has a functional group OH. Now, remember that the functional group is different from the general molecular formula. There are people that were asked to give the functional group of alkanol and they are writing something like this. Now, this is not the functional group for alkanol. Rather, this is the general molecular formula for alkanol. The functional group for alkanol is an hydroxyl, just like this. Now we look at another one, like the alkanoic. The functional group for alkanoic is COOH. The functional group for alkanoic is not RCOOH. This is not the functional group. This is the general molecular formula. And then we have another functional group. Let me add another one here. Alkoxy alkane. Now for the alkoxy alkane, the functional group is the ethyl linkage. Well, the functional group is not like this. This is not the functional group of the alkoxy alkane, but it's an ethyl linkage. So you have known the difference between the functional group and the general molecular formula. A compound that is known as monofunctional compound, they are compound that has just one functional group. Let's give an example of those. Let's say we have this. Okay. Now, let me make this more tedious because we are high school students, we should know. What's this? Now, for this, we're going to start naming from here. 1, 2, 3. This is 2-methyl, 1, 2, 3, propanol. This is 2-methyl propanol. All right, so we name another one. Let's say the alkanoic. Let's say we have C2H5COOH. Now, this is an ethanoic acid. No, sorry, this is not ethanoic. Now, you need to count this carbon atom inclusively in your naming, in your longest chain. So this is propanoic acid. All right, so we have this one. Let's say we have this guy. This is known as diethyl ether. All right, all these are examples of monofunctional compound. Let's go to another one, which is the biofunctional compound. The biofunctional compound, which represent with 2. Now, this biofunctional compound, where we have 2 functional groups in one compound, it is known as biofunctional compound. Let's look at the functional group that have the carboxylic. Remember, the carboxylic is the same thing as the alkanoic group. Now, this has this functional group. And let's say the alkanol, which have this functional group. Now, whenever these 2 functional group appears in a compound, it's called biofunctional compound. Let's have this molecule. Now, notice that you have this functional group there, and you have this functional group. This is called the hydroxyl, and this is called the carboxylic. Now, to name this compound, you need to give priority to the carboxylic functional group. So I'm going to start naming from here, 1, 2, 3. So this is 2 hydroxyl propanoic acid. This is 2 hydroxyl propanoic acid. We will assume that you know how to name biofunctional compound, or compound that has 2 functional groups. Or in case you don't know how to name compound that have 2 functional groups, you can drop you can give us a message in the inbox down there on the message box there, and you tell us to give you a video or give you a class on biofunctional group, how to name biofunctional compound. But if we don't have any message there, we assume that you know how to do that. So we have this compound that have the alkane double bond, and has the alkene triple bond. All right, now let's give that example. Let's say we have CH, C, H. Now, how do we name this? Notice the first functional group there. The first functional group over there is alkene. The last one is this is for this, while this is for this. All right. How do we name this? We give priority to the triple bond. So we'll start counting from here. 1, 2, 3, 4. So this is boots 3 A and 1 I. Boots 3 A, 1 I. So this is a biofunctional group because it has 2 functional groups, alkene, alkyne, and alkane. And let's go to what we have for today, polyfunctional compound, because I told you that to know what something is, you need to know what it is not. Polyfunctional compound is not monofunctional compound and is not biofunctional compound, although there are some examples of polyfunctional compound that is given in biofunctional compound, like the amino acid and carbohydrates. Okay, now let's clean up the board. We're going to start up with 2 examples that we know. And the 2 examples we'll be considering, because if you're studying biochemistry, you are studying giant molecules like the nucleic acid, RNA, and DNA. You are studying carbohydrate, you are studying protein, you are studying biochemical substances. So we're going to deal with the ones that is useful to us. There are many of those polyfunctional compounds, but the major one you should focus on as a biochemistry student is the carbohydrate and the amino acid. There are still a lot of those. So we look at carbohydrate and amino acid. And what comes to your mind when you have amino acids? You see, different monomers of amino is added together to give the protein by a peptide bond. All right. So this is carbohydrate. Now let's talk about, because this is what we're going to be using to study for today. Now let's talk about amino acid. It has the amine group. It has the amine group and it has the carboxylic group. Now this is what makes it the amino acid because of the two functional group. Now this is two functional group, which means it could be bifunctional and it could also be polyfunctional. There's a reason to that, and we will drop. You can, if you know the answer, give us the answer in the comment section. We'd like to engage you. You're a student. The student learn by answering questions. A student learn by research and not just sitting down in the class to receive lectures. When you research, you learn more. Now we look at this one, carbohydrate. We're going to be dealing with two major monomers of carbohydrate, which is the glucose and the fructose. With that, we used to teach you what we mean by polyfunctional compound. For instance, the carbohydrate, the monomers we're using is the glucose. Remember, this is a disaccharide, and the fructose. Now, we have a group known as the carbonyl compound. The carbonyl compound is divided into two. We have the alkanol, and we have the alkanol. So if you're asking the exam, alkanals and alkanol are collectively known as what? The answer is carbonyl compound. And the two types of carbonyl compound we have is alkanal and alkanol. So we have the functional group of alkanal is, let me use another pen, is, we have CHO. All right, for alkanol, we have double bond O. So this is the functional group for alkanal and alkanol. Now listen, this is the general molecular formula for this. This is the general molecular formula for this. I'm saying that over and over again, so you don't take the general molecular formula for the functional group and the functional group for the general molecular formula. Don't do that. All right? So we're going to bring these functional group to this side. Now we have this functional group, which is the alkanal. We have the other functional group, which is the alkanol. Now, if this functional group is, you add an hydroxyl to it. If you add an hydroxyl to it, you're going to be having glucose. You're going to be having fructose. Because of these two functional groups, alkanol and hydroxyl, alkanal and hydroxyl. Now, let's make more expression for you. The carbohydrate has a molecular formula CN or CX, H2N, and then OY. Now, this is the molecular formula, or you have CH2O, N. N is the number of elements in the box there. Now, let's give you the examples of what we mean by carbohydrates being a polyfunctional compound. Let's have some space on the board. All right. Now, we are looking at glucose. We are looking at fructose. All right. For glucose, it has the functional group, the CHO, and then the hydroxyl. For fructose, it has the functional group O plus OH. So that's the functional group over there. Now, if you look at the glucose, is a monomer of that is a disaccharide anyway, but it's a monomer of a monomer sugar, a single unit sugar. It has about 6 carbon atom, 6 carbon atom that makes up the glucose because it's an hexose sugar. Now, if you have 6 over here, 6 times 1, that is should be C6. 6 times 2, that is 12. 6 times 1, that is 6 over there. The same thing we'll have there, C6, H12, and then O6. Now, the first thing to do is that we're going to draw the Fisher's projection on the both sides. The Fisher's projection on these halves. Now, the Fisher's projection is C, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to stop here. So I have OH, H, H, OH, H, OH, H, OH, H, and then over here I have OH, and I have H, and I have double bond O, and I have H. Now, this is known as alpha, not alpha, because the Fisher's projection is a straight chain glucose, is known as the D-glucose, or glucose D, or known as the D-glucose. All right, glucose D or the D-glucose. Now, we have over there, let's use the side of the board for fructose. We have 1, 2, 3, 6, 2. 1, 2, 3, 4, 5, 6. We have OH, we have H, we have H, we have OH, we have H, we have OH, we have H, we have OH, we have H. We have a double bond here. We have H, we have OH, and then we have H. Now, for you to confirm that these things are equal to the molecular formula, the structural formula is the same thing as molecular formula, we can count the number of carbon. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 carbon. Hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 over there. Oxygen, 1, 2, 3, 4. Let's go. 1, 2, 3, 4, 5. 1 is missing. Now, let's check it again. This is 1, 2, 3, 4, 5, 6. Complete. It's complete. Now, if you do that on the other side, you'll find out it's also complete. So we need to draw, this is the Fisher's projection. This is the Fisher's projection. We need to draw the Watt projection. Now, what makes this a polyfunctional compound? You can see there are a lot of OH on the board. Now, there's a lot of OH makes it a polyfunctional compound because it has just 2 functional groups anyhow, but it has numerous number of this OH, hydroxyl, 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 hydroxyl over there. All right, and it also has the arcanone, the carbonyl compound, and we have the OH, hydroxyl, hydroxyl, and it has the arcanal, one of the carbonyl compound. All right, so we have the Watt projection looks like this. This is CH2OH. This is H. Let's call this H. OH. Let's call this OH. Let's call this H. OH. Okay, sorry. Let's call this H. Let's call this OH. Now, over here, be careful. Now, in this side of the board, if you put an OH here and you put an H here, this will become a beta D glucose. This will become beta D glucose. Now, this is known as beta D glucose. If I should remove the OH and place it here and get the H up, it will become an alpha D glucose. Now, I believe you have written this now. Now, let me change this to an alpha D glucose. I'm going to remove this here and remove this here, and I'll put an H here, and I'll put an OH here. This will become an alpha D glucose. Now, if I'm talking about the Watt projection for the fructose there, all right? Now, you can decide to count the number of carbon atoms. You'll see 6. Number of hydrogen atom, you also notice it is 12. Number of oxygen atom is also 6. You can do that on your own. Let me help you. 1, 2, 3, 4, 5, 6. Then do the rest. You'll find out it's the same thing. Now we have for this homeward projection of this guy, it's like this. This is CH2, OH, this is OH, this is OH, this is H, this is OH, sorry, this is H, this is OH. Now over here, you need to be very careful. If you want to have an alpha fructose, alpha D fructose, that means that the CH2, OH, this compound over here, are you following now? Okay, this should be H, or sorry, this should be OH, rather this should be H. All right, now the this molecule here should be on top if you want to have the alpha D glucose, fructose, sorry. Now for the alpha D fructose and alpha D fructofuranus, you need to know there's a different, they are mostly the same structural configuration, but there are slight difference between them. So for you to know the difference between them, but we believe you should know. But if you don't know, you can tell us, you can ask us, we're gonna know, we want to engage you in this class. So that if you need the video or if you need a class on that, we're gonna have a class on that. But if we don't have a message there, we're gonna assume that you know the difference between alpha D fructose and alpha D fructofuranus. And also for the alpha D glucopyranus or pyranus, all those that. Now, if you remove this guy and put him somewhere here, CH2, OH, and you transfer the OH over here, you're going to be having the beta D glucose. Now you can see the difference between this guy and this guy. If the OH is down, it's alpha D glucose. If it is up, is beta D glucose. If the CH2O is down, it is beta D glucose. If it is up, it is alpha D glucose. Now, this is what we need to know about the polyfunctional compound. Although we are going to be studying carbohydrate as a topic, amino acid as a topic. This is just an introduction for you to know what we mean or what we meant by polyfunctional compound. And at this point, you should be able to differentiate between bifunctional compound, monofunctional compound, bifunctional compound, and polyfunctional compound. Thank you very much for watching. Have a great day.